Alright, today we're going to talk about solving quadratic equations. There's two methods that we're going to talk about solving today. The first one is the quadratic formula. Hopefully you already remember the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. Maybe you learned a song about this in junior high. If you want to sing it, go ahead. It's also kind of fun to YouTube versions of the quadratic formula song. There's some pretty funny ones out there. Alright, so let's talk about how to use it. Probably the most important thing with the quadratic formula is making sure that your equation equals 0, moving everything to one side first. Then, a is the number that's in front of x squared, b is the number that's in front of x, and c is your constant term. After that, it's just a matter of plugging things into the formula. So we've got x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 10 all over 2 times 1. When you simplify that, you're getting negative 4 plus or minus the square root of 16 minus 40 over 2. Don't get worried if you have something negative underneath the square root. We don't have to say no solution anymore. We can simplify and just have an I in our answer. So since we also know the perfect square that goes into 24 is 4, I'm looking at negative 4 plus or minus 2I root 6 all over 2. And then, since negative 4, 2, and 2 are all divisible by the same thing, they're all divisible by 2, I can simplify my final answer to be negative 2 plus or minus I root 6. Alright, number 2 is pretty straightforward as well. Again, first thing I'm going to do is just move everything over to one side. It doesn't matter which side you move things to. I'm going to identify my a, b, and c. This time I've got a is 3, b is negative 7, and c is 4. And then just plug it into the formula. X equals 7 plus or minus the square root of negative 7 squared minus 4 times 3 times 4 all over 2 times 3. Remember that when you square a negative number, it's always going to turn to positive. So we're looking at the square root of 49 minus 48. This one comes out kind of nicely because it's the square root of 1, which is just 1. 7 plus 1 is 8 over 6, which reduces to 4 over 3. 7 minus 1 is 6 over 6, which reduces to 1. Alright, the next two problems are where things get interesting. For number 3, you could work with the equation just like it is, but you're going to end up having a fraction for b. That might be a little bit ugly to work with. So remember, a technique that we've learned this year is that we can actually clear out the fractions by multiplying through by a least common denominator. In this case, the least common denominator would be 2. This is a much nicer equation to work with. 2x squared minus 3x minus 2 equals 0. Now my a is 2, b is negative 3, and c is negative 2, and it's just like the ones up above. So x equals 3 plus or minus the square root of negative 3 squared minus 4 times 2 times negative 2 all over 2 times 2. One of the things that I want to emphasize too is to treat the minus 4ac as another negative sign. So we're looking at 3 plus or minus the square root of 9. Negative times negative is going to be plus 16 all over 2. 9 plus 16 is 25. The square root of 25 is 5. So 3 plus or minus 5 over 2. 3 plus 5 is 8. Over 2 is 4. 3 minus 5 is negative 2. Divided by 2 is negative 1. So my two answers are 4 and negative 1. I'm going to use a similar technique on number 4. I can't really do the quadratic formula without doing this step. So I'm going to first multiply the entire problem through by x squared. Now I've got x squared minus 2x minus 2 equals 0. The x squared and the x did battle in the top one by one. So now I've got a is 1, b is negative 2, and c is also negative 2. Plugging this in, I'm looking at x equals 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 2 all over 2 times 1, which then gives me 2 plus or minus the square root of 4 plus 8 over 2. 4 plus 8 is 12. Again, I can simplify my root with a perfect square. 12 is 4 times 3. So I'm looking at 2 plus or minus 2 root 3 over 2. Now be careful when you're simplifying this. Remember that the 2, 2, and this 2 in the bottom are all divisible by 2. So my final answer is 1 plus or minus 1 root 3. It is not 1 plus or minus 2 root 3. The 2 that's in the denominator gets divided with both of the terms on the top. Alright, now I'm going to teach you a second method for solving quadratic equations that always works. It's called completing the square. The idea is that we're going to create a perfect square on one side of our equation so that we can solve with the square root method. We're going to start by subtracting the 5 over to the other side. So we've got x squared plus 6x, leave some space, equals negative 5. Now remember, the goal was to create a perfect square over on one side of the equation. That's going to be the left side. So we're going to bring the b, the term that was in front of the x, off to the side. We're going to divide by 2, which in this case is 3, and square it so that we get 9. So on both sides of the equation, I'm going to add 9. Now if you're not using different colors, what I would suggest here is making sure that you underline where you're adding that term in. That will help you to know that that's what you added to both sides. Now the left-hand side, if we were to factor it, would factor to x plus 3, x plus 3. Another way for us to write this is just x plus 3 squared. On the right side, negative 5 plus 9 is 4. Now that we're at this point, we can just solve with the square root method. We can square root both sides. So we have x plus 3 equals, make sure that when you square root both sides, you put down plus or minus. So we're looking at x plus 3 equals plus or minus 2. Then we'll just subtract the 3 over. Negative 3 plus 2 is negative 1. Negative 3 minus 2 is negative 5. So our two answers here are negative 1 and negative 5. Now there's a few catches when you're doing completing the square. The first one is we can only have one x squared. So for problem number 2, the first thing we need to do is divide each term by 3, the leading coefficient. So now the equation we're looking at is x squared minus x minus 11 equals 0. Now we can proceed just like we did before. So I'm going to move the 11 over. X squared minus x, leave some space, equals 11. I'll bring the b term off to the side, which this time is negative 1. Divided by 2 is negative 1/2. Squared is positive 1/4. So on both sides, I'm going to add 1/4. Now, you may be thinking, I have no idea how to factor x squared minus x plus 1/4. The good news is you don't really need to. If you noticed on our last problem, the part that we had in parentheses led us to our parentheses right here. So the same thing is going to happen when we're looking at our new problem. The part that's in the parentheses here is going to lead us to our parentheses here. So this actually factors x minus 1/2 squared equals 11 plus 1/4, which is 45 over 4. I like to make that an improper fraction because then when you take the square root of both sides, you're ready right away to say, okay, I've got x minus 1/2 on the left. The square root of 45 is 9 times 5. So that's going to be plus or minus 3 root 5 over the square root of 4, which is 2. Now when I add the 1/2 over, I already have common denominators. So my answer is 1 plus or minus 3 root 5 all over 2. Alright, for this last one, again, first thing we have to do is divide by the leading coefficient, which is 2, but this time we're still going to be left with a fraction for our b. That's okay. It won't be impossible to work with. So first thing I'm going to do is move over the 1. X squared plus 3 halves x equals 1. Then I'll take that 3 halves, which is my b, off to the side. Instead of dividing by 2, I'm going to multiply it by 1/2, which is the same thing as dividing by 2. So I'm going to get 3 over 4 for what goes in my parentheses. 3 squared is 9, 4 squared is 16. So I'm going to add 9 over 16 to both sides. Again, don't panic that you're going to have to factor something that looks like this. Parentheses go to parentheses. So this is just x plus 3/4 squared equals 16 plus 9, which is 25 over 16. Now I'm ready to square root both sides. I've got x plus 3/4 equals plus or minus the square root of 25, which is 5, over the square root of 16, which is 4. Now when I go to subtract the 3/4, again, I've already got common denominators. So I'm looking at negative 3 plus or minus 5 all over 4. Negative 3 plus 5 is 2 over 4, which reduces to 1/2. Negative 3 minus 5 is negative 8 over 4, which reduces to negative 2. So my two answers are 1/2 and negative 2. Alright, the last thing for today is, have you ever wondered where the quadratic formula comes from? It's not like some random mathematician was just thinking one day, I know what's going to solve every quadratic equation. If I take the opposite of b plus or minus the square root of b squared minus 4ac over 2 times a, that's going to work every time. It actually comes from completing the square. So take a look. If we start with our general quadratic equation, we know that we can only complete the square with 1x squared. So first, we're going to divide each term by a. Now, we're left with x squared plus bx over a plus c over a equals 0. Our next step in completing the square is moving the constant term over. So x squared plus b over a times x, leave some space, equals negative c over a. Alright, now we're going to bring the b over a off to the side. Since it's a fraction, instead of dividing by 2, we're going to times by 1/2. So I've got b over 2a. Then I'm going to square that, so I've got b squared over 4a squared. That's what I'm going to add to both sides. On the left side, I'm going to factor. Don't worry if this looks hard to factor. Remember that parentheses are going to go to parentheses. So this is just going to be x plus b over 2a squared equals, on the right side I'm going to get common denominators. So my common denominator is 4a squared. So I'm looking at negative 4ac plus b squared. Maybe that's starting to look familiar. Alright, now I'm going to solve with the square root method, so I square root both sides. X plus b over 2a equals plus or minus the square root of 4a squared on the bottom is 2a. On the top, I'm just going to leave it underneath the root, and I'm going to switch the order of terms. So b squared minus 4ac. As you can see, we're almost there. Now I'm going to subtract the b over 2a. I already have common denominators, so here's my answer. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's where the quadratic formula comes from. Now you know, it's not just something that some guy randomly thought of, but it's actually pretty mathematical where it comes from. Hopefully you'll be good to go on your homework for tonight, quadratic formula and completing the square.